68 of Neetcode 150 subsets. So we are going to be given an array of integer, and there won't be any duplicates. We are going to have to return all the possible subsets that we can do with these numbers. Let's go see the example 1. We have an array nums containing the integer 1, 2, and 3. And with these values, the first subset we can do is actually an empty subset. Then we can have a subset containing only 1, a subset containing only 2, another one containing 1 and 2. And notice that the order in which the values appear in a subset don't really matter. All right, so that's the reason why in our output we don't have another subset composed of a 2 and a 1 respectively. So as far as both values are within a subset, permutation doesn't make it a different subset, okay? If we continue, we see we can have a subset containing only 3, another one containing 1 and 3, another one containing 2 and 3, and finally another one containing all the values. So this is all the subsets we can make with an array containing 1, 2, and 3. There are two ways to solve this problem. The first one is by using backtracking, and the other one is by using iteration. I'm going to show you both. In terms of time complexity and space complexity, both are equivalent. So it is really up to you to decide which technique you are more comfortable with. So let's first try to picture what we are going to do in the backtracking. How is it going to look like? So let's give us an idea. First, we are going to have our first value of 1. And when we are at 1, there's going to be a choice. So we either add to the subset the value 1 or we don't. And this choice is going to be the same for every single value that we're going to encounter. So at 1, we can decide to have an empty subset, or we can decide to add 1 to the subset. All right. So now we have one number and we created 2 subsets for it. So notice that for each subset that we are creating, we are going to add 2 subsets for each subset that it creates. So it's going to have, so this itself will have a time complexity of 2 of n. And we're going to have to multiply this by n because we are going to recurse through every single value inside the array that we're given. So this is going to be your big O time complexity. Okay. So let's continue. Now we are at 2, and at 2 we have 2 arrays. And the first one, we can decide to leave it empty, or we can decide to add our 2 in it. Right, so this is the level where we are at 2. Okay, this is the level where we at 1 above it. So on this empty array, we can either add 2 or leave it as it is. And same thing here, we can either leave it as it is, so let 1 be the only value in the subset, or add 1 or add 2 to the subset. Okay, and same principle for the 3. So now let's say this is our level 3. So when we have our empty subset, we can either decide to leave it empty as it is, or we can decide to add 3 in it. Okay, and same process for the 2. We can either decide to leave it as it is with a 2, or we can decide to add a 3 to it, so it will become 2, 3. And now same principle for the 1. I'm running out of space, but I'll keep going. So you can either let 1 as it is, or you can add 3 in it, so it will become 1, 3. And finally, let's just remove this, and let's also move a little bit. Okay, so after the 1 and 3, we are going to have this subset containing 1 and 2, so we can decide to either let 1 and 2 be 1 and 2 as they are, we don't touch them, or we can decide to add 3. So it will become 1, 2, and 3. All right. So this is the first approach. We see that on the bottom layer, we have all the possible subsets, and this is using backtracking. Now, let me quickly explain how we can do pretty much the same or achieve the same results with iterations. So with iterations, it takes a while. Okay, so with iteration, we are initially going to create a subset. So we're going to create a subset, and within this subset that we initialize, we are going to create an empty subset. So now we are going to say for each numbers, basically add this value to all the current subset in our output array, but we don't want to remove the previous subset. So you can see that if we call this O, you can see that in O we currently only have a subset, an empty one. So we're gonna say add 1 to all the current subset. So basically we're gonna add 1 to an empty subset, and we are gonna add this to O. So O will become basically it will keep its empty array, right? Because we are not modifying what is already in there. We are just adding on it. So we have 1, and now when we have 2, we are gonna take all the values in it, and we are gonna add 2 in all the subsets. So initially we have an empty subset in which we're gonna add 2, right? And then we have a subset with only a 1, so it's gonna become 1, 2. All right, and what we got here is going to be added to this, okay? And I think you got the concept. After this, we are going to do the same thing with 3. So we are going to add 3 in an empty array, just like this. We are going to add 3 to an array that contains currently 1. All right, and we're going to add 3 to, I keep saying array, but let's just call them the subsets. So we're going to add 3 to the subsets that contain only a 2. And finally, we're going to add 3 to the subsets that contain currently 1 and 2. So this is going to be what we are going to add at the end on O. And notice that at the end, O is going to contain all the possible subsets that we can create with the values you are given in nums. So first, let's just do the backtracking solutions. So we are initially going to set our output. It's going to be an empty list, and we are also going to create the subset. And now we are going to use a depth first search. So let's call this function that we're going to create to do our backtracking DFS. And I'm actually writing I as a parameters because I actually want to go through each values inside nums, inside the list we're given, and I will do so by using the index. So when I'm going to call the function, let's do it right now. I'm going to call it at the index 0. And after this, I will return the output. So this is the reason that I'm passing I in DFS. And the first check that we want to do in DFS is what if the value of our I is equal to the length of the nums. It must mean that we are out of range, right? So we're out of bounds. So we have to make a return statement here. So we're going to say that if I is equal to the length of nums, okay, this is where it means that we have found a subset. We reached the end of the recursive call, and we can start doing backtracking, so we can return our statement. But before we return, we actually want to add a copy of that subset into the output. So we're going to set output dot append, and we want to add the subset, and we have to make sure that we create a copy, so we don't we don't lose our the subset that we found in that recursive calls. And once this check is done, we can create the two big questions that we ask ourselves and the two big decisions that we are going to have to take. So the two decisions are basically, do we want to add that numbers, or we want to leave it as it is, right? So first, if we want to add these numbers, well, we are going to say subset, and we are going to append to that subset that nums at the index I that we are at. Okay. And we are also, once we have our new subset here with the value of num at the index y appended to it, we are going to pursue we are going to call our recursive call. So we're going to say DFS, within which we are going to go see, we're going to go send the next number. Okay. And this is the code that we have to write for the decision where we actually add the value in the subset. But to account for the decision where we don't add that value in the subset, well, we're just going to say subset, and we're going to pop the value that we just added, meaning that we didn't add any value, and we are going to continue our recursive call without that value. Okay, so that's actually it. You can now submit the code. So this was the backtracking technique, and now I want to show you a technique that takes less code, the iteration one. So let's just remove what we did. So for the iterative approach, we are initially going to have our output, which is going to be equal to this array, and we want to add an empty one when we start. And we are going to go for every single number inside the array of numbers we're given. And for each of these numbers, we basically want to have like a copy of all the current subsets within output. And within every single copies, we want to add this number to it, and then take all these copies and add it or extend our output with these other subsets. So we are going to do this in one line. We're going to say output plus equals, and now we want to add basically this array, and we are basically going to say for the subset in output, and what we want to do for each subset, we want to take the current value, so we're going to say subset, and we are going to add that number to it. So that is the entire solution. We can now return the output, and it's going to give us all the possible combinations we can have with the numbers that we are given. All right, so I hope you learned from this video, and I hope to see you in the next one.